Yes guys, so what I am considering here, the question number 2. Now in this case we have taken that there are 3 events A1, A2, A3. What is A1 event? That A1 be the event that bolt selected is from machine or is manufactured by machine A. A2 manufactured by machine B, right? And A3 manufactured by machine C. These are 3 events which are given to us, that these 3 machines are manufacturing bolts in percent, so their percentage is given. And B is the event that bolt selected or bolt which was drawn is defective. Defective is the common feature which we have to select. Or it says that what is the probability that selected bolt which is defective, because it says that a bolt is drawn which is found to be defective. We have to find that what is the probability that it is selected by it is manufactured by the machine B, the bolt selected which is defective. Now first let me take what the probability is given to us. So defective, which is B1, B event, the defective bolts. Let me find a solution. The solution. Okay. So the defective bolt. Now try to understand here. Here it says that probability of we are given, so we are given here. So we are given here probability of A1. A1 means the bolt manufactured by machine A. You see that? What is that? 25%. 25 upon 100 is first event. Probability of A2 is how much? 35%. 35 upon 100. And third is probability of A3 event that manufactured by machine C. Third machine, or we could take A, B, C, no problem. And D could be taken as defective event. So whatever you select, you assume, whatever you assume, that is up to you. But because I take only A1, A2, A3, which are given to us the trial probabilities, right? The prior probabilities. The prior probability I always take A1, A2, A3, that's why I take, and B as the common event which is intersecting of all the, or intersection of all the given events. Right, so B I take, in this case, defective bolt. Now A3 is given 40%. They are manufacturing, machine A manufacturing 25%, machine B manufacturing 35%. A3 or event selection of probability A. A3 means manufactured by machine C. C machine is manufacturing 40% of the bolts. Now, what the probability? Now, what is further given? The defective products from machine A. That means B oblique A1 is how much? How much is defective product by A machine? 5%. 5% were defective of machine A. And 4% were defective of machine 2. One means B machine, this is 4%, right? And C, defective products of machine C means A3. A3 are taken as a machine C, right? A, B, C. The 3 machines, A1, A2, A3 are taken, not A, B, C. Just try to understand, please don't confuse. This is 2%, I think. This is given to us as 2%. What is it? 2%, 2%, right? So 2 upon 100. Now these are the likelihood events, right? Likelihood probabilities. Likelihood probabilities are these are the prior events or prior probabilities. Prior probability, likelihood probabilities, multiply them and you will get that. But in this case, second machine B is manufacturing 35. The product will be defective one and is also manufactured by machine B. That means we have to multiply this 4%, because 4% are defective products manufactured by machine B. So this 35 upon 100 into 4 upon 100 will be in the numerator multiplication, right? So probability of, let me take, hence probability that products or bolt selected or drawn is defective and is manufactured by machine B. Machine B is given by probability of, we have taken this as A2, try to understand. So probability of A2, right? Probability of B upon A2 we have to find out. Probability of A2 machine B on B is the defective products. This is equal to probability of A2 into probability of B oblique A2, try to understand, divided by probability of A1 machine A into probability of B oblique A1 plus probability of A2, this one, into probability of B with respect to A2 machine B machine A, A1 machine AA, right? B is the defective event, plus third one probability of A3 by machine C into probability of products manufactured or bolts manufactured by machine C, probability of A3 into probability of B oblique A3. Now substituting the values, let me put this above. Let me put it here. So this formula is Bayes theorem. Hence, by Bayes theorem or applying Bayes theorem, applying the Bayes theorem, we have probability of A2 defective products manufactured by machine B. B here are taken as defective products, right, or defective event. This is this value. Probability of A2. Now A2 is how much manufactured by machine B? 35%. Is 35 upon 100. 35 upon 100 into how many? 4% were defective. Bolt defective found by machine A, but 4% only. Now divided by this whole, which is 25% by machine A, manufactured machine A, and 5% were defective here. So 5 upon 100 plus this 35 upon 100 into 4 upon 100 plus last is 40% upon 100 manufactured by machine C, which is 40%, so 40 upon 100 into 2 upon 100. 2% were defective, which were from machine B, right? This is total sum. Now let me further solve it. So here we get, for the final answer, let me remove 100 into 100, take an LCM from numerator and denominator and cancel out. We can write here 35 into 4 divided by 25 into 5 plus 35 into 4 plus 40 into 2. It will give us 40 into 35 to the 70 to the 140. It is 140 here. 25 5 to 125 plus 140 plus 80. What is this? This is 140 upon total sum 0 plus 0 5, because 5 is there, 8 plus 4 12 plus 2 14, 4 1 carry, 1 plus 1 2 and 1 3, 345. Okay, so this can be further simplified. Okay, let me write it here. So finally we get 140. What is the probability of that? So probability we are finding out. We will keep this probability only. Let me cancel out with 5. 5 to the 10, 4, 5 is the 40. Okay, 5, 6 is the 30, 4, 5 is the 35. Now it is not cancelled out. I think 3 low. It's odd number, the even number, odd number. So only 28 upon 69. So what is this? This probability of the bolt drawn is defective and is manufactured by machine B. Hence 28 upon 69 is the probability that bolt drawn which is defective okay is manufactured by machine B. This is the point, by manufactured by machine B. That is the answer here. 28/69 is the probability that it is manufactured by machine B. Okay, and that product is, that bolt drawn is defective. That is also good. Okay, now question number 3 let me take. What is question number 3? But before that, let me clean this. Before taking question number 3, let me put that. Yes, friends, so question number 3, what does it say? Let me just check it first and then solve it. Yes, question number 3. What is given to us? First, let us write it here. Question number 3 says, this is question number 3. Question 3 says, an insurance company insured 2,000 scooter drivers, alright, and 4,000 car drivers and 6,000 truck drivers, an insurance company, right? So they have insured. Now the product's probability of an accident. Now the probabilities of an accident involving a scooter driver, a car driver and a truck driver are this and this. Probabilities are given. Alright. That's good. Now one of the insured persons or driver meets with an accident. Now, what is the probability that he is a scooter driver? Good point. Again, based on, so this is how we have to decide about out of this person was a scooter driver, was a car driver, was a truck driver, whatever. But here we have to find that he was a scooter driver. What is the probability of that? Completely. Here the person who met with an accident, the driver who met with an accident was a scooter driver. What is the probability of that? That we have to find out. Let me take what is given to us. We are given here an insurance company okay, it says an insurance company insured 2,000 scooter drivers. Yeah, scooter drivers. Very interesting question. Scooter drivers, right? 4,000. Further says 4,000 car drivers. 4,000 car drivers and 6,000 truck drivers. These are truck drivers here. Okay. Now, further says the probabilities of an accident. Probabilities of an accident involving a scooter driver. A car driver and the truck driver and a truck driver all right. and a truck driver are, what are those probabilities? Are, we are given here 0.01, right, 1%, 0.03 means 3%, and 0.15 means 15%, right, respectively. It says no problem. Now we have to find out one of the insured person meets with an accident is given to us. One of the insured persons, it says one of the insured persons meets with an accident, right, with an accident. One of the insured persons meet with an accident. To find here that person who met with an accident was a scooter driver. Probability of that. What is the probability? We have to find out the probability. To find the probability that it was a scooter driver, that he was a probability that he is a scooter driver. Good point. Is a scooter driver. All these questions I think were given by some students, and they were telling me some very important questions. They have appeared in the exams. I don't know which exam they have appeared. Maybe competitive examination, maybe technical course examination, maybe 11th, 12th, I don't know which, but very important questions these are. Okay, these are based on, again, Bayes theorem. We have to apply here. What the Bayes theorem says, let me find the solution from here. From here, let me find the solution. Now try to understand. We will take A1, A2, A3, the three events, and met with an accident, right? From met with an accident, event is B. Let me take again. Let me take let A1, A2, and A3 be the event of insurance or percentage of the insurance, or we can say probability of the insurance. A1, A2, A3 be the event of insurance of the persons. Right? So probability of A1 means first is scooter, I think. Scooter, second is car, and third is. So let me take them respectively. So here, or let me take A1 to be the event of scooter driver. Okay, insurance of the scooter driver. Be the event of insurance of a scooter driver. This is a scooter driver. What the probability, I'll just find out. A2 event of insurance or insurance of a car driver. Simple. And third one, A3, third event is the event of insurance of a truck driver. Right? Of a truck driver. So what is the probability of them? I mean, probabilities are given to us. Total number of, we can take, so probability of, therefore probability of A1, how many total scooter drivers were? 2000. This is 2000 divided by total number of drivers. 2000, 4000, 6000 plus 6000, 12,000. It is 12,000. Try to understand. Sum of all the drivers, scooter driver, car drivers, and truck drivers, and out of that 2000 are there. So this is probability of insuring scooter drivers. This will give us 1.6 here, 3 zeros cancel out, 1.6, right? 1.6 is the probability of insurance of scooter driver, and probability of A2 is 4,000 upon 12,000. This is 1.3, 4 upon 12. That means 1.3. And what is probability of insurance of scooter drivers? Sorry, truck drivers. This is scooter driver. This is car driver. This is second equation. This is first equation already there. And probability of A3 is 6,000 upon 12,000. 12,000 is total number of drivers of scooter, car and truck. Total in the denominator and number of particular vehicle, either other scooter, car or truck is in the numerator. That is 1.2 here. This is third equation. Now, met with an accident, right? One of the persons who is insured here, these are the probability of them. Now the percentage probability of their, that is also given. Here B is the event. Here B we have taken, and event of, this is the event of getting an accident, right? Involving an accident, okay. An event of meeting with an accident, meeting with an accident, or we can say this event is, so percentage of that. Now this person is scooter driver, what is the probability of that given to us? We are given here that A1 upon B here, and we are given here probability of A1 with respect to B. What is this B? Accident met by a scooter driver. Probability of that is given to us as 0.01. Probability of A2 is, this is of scooter driver, this truck driver's probability is of meeting with an accident 0.03, 3% only. And probability of A3 with respect to B means B is the accident of truck driver, is, what is the probability of that? 0.15, 15%. Okay, so these are the likelihood probabilities. Now we have to find out that what is the probability of what I'm doing here. We have to find out that what is the probability of this. This is B upon A1, because this is accident here. I'm sorry, I just always forget this point. Why I'm just forgotten this, not always. At the moment I forgot. This is the probability of B oblique A1. That means the accident happened with the scooter driver is this, probability of that, and probability of B oblique A2 means car driver's accident is this person, this probability is given, and third is B oblique A3. This is very important point, because these are likelihood probabilities. Likelihood probabilities are accident met of a car driver, of a scooter driver, of a truck driver, they are given to us. Okay, so let us take now that accident met person is a scooter driver. What is the probability of that? This we have to find out. A1 upon B. A1 upon B we have to calculate, which is the posterior probability. B upon A1 is this, right? So now let us take what is the probability of that. We have to find out using Bayes theorem. The probability that the person met with an accident with an accident is a scooter driver. Is a scooter driver. What is that event? This will be probability of A1 oblique B. A1 is the scooter driver. Okay. A1 we have taken the event of scooter drivers meeting with an accident. So A1 upon B is, let me write here, probability of A1 into probability of B oblique A1, which we just calculated, divided probability of A1 into probability of B with respect to A1 plus probability of A2 car drivers, probability of car drivers into probability of meeting with an accident. This is B oblique A2 plus probability of A3. This is truck driver's probability, right? Into probability that the accident happened with the car driver, with the truck driver, is B oblique A3. Right? So this is prior probability, likelihood probability, prior probability, likelihood probability, prior probability, likelihood probability, prior probability, and this whole will give us posterior probability. Now let me put the values of this. What are those values? Let me write here finally. Okay, so this probability of A1, therefore A1 oblique B, that accident met person or person who got accident or who was involved in accident was a scooter driver. That probability we have to find out. This is probability of this whole, probability of A1, right? The scooters insurance. This is insurance of the scooters people. 2000 upon 12,000. That means 1.6 into probability of B upon A1. The probability of this given accident 0.21. That means 1 upon 100. 0.01 upon 0.01 only. That means 1 upon 100 divided by 4. 1.6 into 1 upon 100 plus second was 4,000 is 4 upon 12,000, 1.3. It was 1.3 into accident is 3 upon 100, 3% or 3 upon 100, 0.03. This is the that a truck driver met with an accident or a scooter driver met with an accident. A scooter driver, car driver, truck driver's probabilities meeting with an involving a scooter driver, etc. So accident people. This is 1.2. Truck drivers, 6,000 truck drivers were insured. This is 1.2 here, 6,000 upon 12 into 15%, 15 upon 100. What this will give us, let me now take it further. Solving this. So scooter driver will meet with an accident. The probability of that is this. So 1 upon 100, 100 cancel out. Let me take 1.6 in the numerator divided by, in the denominator we will get 6 LCM. It is only 1 plus here 2, 3 is 6, 3 2 is, so 3 cancel out. This is 6 only, for 3 cancel out. It is 6 only plus here 15 2 is, 15 3 is 45, for 2 6 is, 2 3 is 6, 3 times 15, 45. Okay, so this is okay. 6 are taken the LCM here. The 6 is cancelled out. 1 upon how much? So 1 upon this value is 6 plus 1 7. 7 plus 45 52. 1.52. This is the probability here. Answer is 1.52. The probability of the scooter driver meet with an accident or had met with an accident, met with an accident is 1.52. His probability of meeting with an accident. So this is his probability. Okay. 1.52. Finally,